Okay, we are going to finish up Unit 3. And previously we've been talking about mole relationships and chemical equations. Now we're going to talk about mass relationships. Um, so we had been working on balancing chemical equations. We know that these coefficients refer to molar ratios. So if we want to carry out this chemical reaction and we want to react 2 moles of aluminum with 3 moles of sulfur, I need to weigh out the correct amounts. And so reactions happen in mole-mole ratios, but it's much more convenient for us to weigh out quantities. So we weigh them out in grams. So being able to convert between grams and moles allows us to determine exactly how much of the reactants we need to measure out in order to get the products we want. So if we need 2 moles of aluminum, the atomic weight for aluminum is 27 grams. So it's 27 grams per mole. So for this reaction, we need 2 moles of aluminum at 27 grams per mole. So that would give us 54.0 grams of aluminum. And then for sulfur, 3 moles of sulfur. Sulfur weighs in at 32.1 grams per mole. So 3 times 32.1 gives you 96.3 grams of sulfur. So it's much easier for us to weigh out the aluminum and the sulfur as opposed to trying to calculate the amount just based on the moles. So if we go to the next page, there are more practice problems. And these are going to be indicative of what you'd see on an exam. So using the following balanced reaction, calculate how many grams of PbO, lead 2 oxide, would be produced from 1 mole of lead 2 sulfide. And then the molar mass is provided. So the way I like to do these is to set them up as a conversion problem. So where you're starting with 1 mole of PBS, and this is a little bit different than the way the notes explains it, but it just makes more sense to me. So you start off 1 mole of PBS, this is our starting quantity over 1, and then you're going to use the coefficients here and here as conversion factors because they're moles. So 2 moles of PBS over 2 moles of PbO. So that's really just a 1-to-1. And then we can use the molar mass of PbO. So this is how it kind of all links together. 223 grams over 1 mole. And so then you will enter this into your calculator. This one is just 1 times 223. I mean, you could do the divided by 2 and multiply by 2, but you would end up with 1. So you get 223 grams of PbO. Okay. So the next question. How many moles of pH3 would be produced from 364 grams of calcium phosphide? Okay, so we're starting with calcium phosphide. The coefficient there is blank, so that means a coefficient of 1, and we're trying to get to pH 3. So our starting quantity is going to be what's given, 364 grams of calcium phosphide. And so now we're trying to get to moles of pH 3. So this is our starting quantity. We're going to use the molar mass. So we're going to divide 182 grams for 1 mole. And this is, oops, Ca3P2, sorry, squinch that in. Now I'm going to use these coefficients. So 1 mole of calcium phosphide is equivalent to 2 moles of pH3. So it's 364 divided by 182 and then multiplied by 2 gives us 4 moles of pH3. And again, the notes explain it a little bit differently, but I'm just doing unit cancellation and it makes a little bit more sense to me. A road map would look like grams to moles. Okay, to and then moles pH3. So it just gives you kind of a little visual of where we're going with these conversions. Okay, the next problem. Using the following balanced reaction, calculate how many grams of SO2 would be produced from 68 grams of H2S. So this is going to be starting quantity. So we're going to put that 68 grams of H2S over 1. And need to figure out, so we're going H2S to SO2. So here's what we're going to do. We're going to go grams of H2S, moles of H2S, and then 2 moles of SO2, and then 2 grams of SO2. So we got to convert our grams to moles. Make sure we use the right molar mass. So 34 grams, 1 mole H2S. Now I'm going to go 2 moles H2S to 2 moles SO2. And then 64 grams SO2 over 1 mole. Okay, so we get, so in our calculator we're going to do 68 divided by 34 divided by 2 times 2 multiplied by 64. So it looks like that. And we'll get 128 grams. So if you're going about this a different way and you're getting the same answers as me, that's fine too. It's sometimes easy to get lost, to lose your path. And that's why I kind of like to have these roadmaps, but you know, just keep practicing these and they will get easier. Okay, looks like I have one that got divided up. Okay, let me go to the next page on this one. Sorry about that. Okay, so using the following reaction, P4O10 plus, or 6O2 gives you 4H3PO4. Calculate how many grams of H3PO4 would be produced from 568 grams of P4O10. Okay, so you're going to have, okay, so this is your starting quantity. Sorry if you can't see that very well. Okay, so you have grams, P4O10, to moles, P4O10, to moles, H3PO4, to grams of H3PO4. All right, so the way we would set this up, 560 grams, P4O10 over 1, divide that by molar mass, P4O10. Look at the coefficients. 1 mole of P4O10 to 4 moles of H3PO4. And then grams. 1 mole, 98 grams. Okay. So 568 divided by 284. Times 4 times 98 gives you 784 grams of H3PO4. Okay, the last problem, you're going to be, again, doing the same thing, using your coefficients as conversion factors as well as your molar masses. So you're going to calculate how many grams of SO2 will be produced from 239.6 grams. So you're going to go, your generic one for this is grams to moles, and then to grams again. And so at first glance, it might not look like you're doing any conversions, but you're going from grams of FeS2, moles of FeS2, to moles of SO2 to grams of SO2. So it's different because you're actually converting to different chemicals. All right, so what we will do, 239.6 grams of FeS2 over 1. And then 119.8 grams mole FeS2, and then so we have FeS2 to SO2, so 4 moles of FeS2 to 8 moles of SO2, and then 64 grams, 1 mole. So it's grams to gram, or grams to moles, moles to moles, moles to grams. All our units cancel out. These problems remind me so much of high school chemistry, and I had such an awesome teacher. Mrs. Mood is what got me interested in chemistry. But part of why I liked chemistry was it was hard. I had never worked so hard as I did in Mrs. Mood's class. So I think a lot of times students think, oh, chemistry must have been really easy for you. It's easy for me now because I've been doing it for so long, but I definitely struggled with it. And I can remember many an afternoon locked away in my room studying chemistry, but I really started to like it and love the challenge and trying to figure out the problem solving. So, if you're not getting it right away, keep your head up and keep plugging away because you will get it. And it clicks. You know you've got it. Okay, so I'm just entering this into my calculator. Now, when you have this set up this way, I'm going to write this out. You might think it's silly, but I want to make sure everybody understands this. So I am putting 239.6 divided by 119.8 divided by 4 multiplied by 8 multiplied by 64. So if you have anything on the bottom, you divide by it. If you have anything on the top, you multiply by it. Okay, so times 8 times 64. And then you end up with 256. Okay, so with all of these problems that involve chemistry, I have, put together a few examples, and these might help you when you're working through your homework problems. I definitely recommend referring to them when you're working on your homework problems. I think one thing that can always help you is standing back and looking at what you're doing and not getting caught up and trying to not getting caught up with the anxiety, because you can definitely generate a ton of anxiety for chemistry. I speak from experience. But step back and say, okay, really chemistry is about conversions. It's converting one chemical into another. It's converting one unit into another. And so if you just kind of step back and try to figure out how am I going to get these units to cancel out, you'll get a lot further than just kind of jumping around and plugging in numbers. And so these tips that are put together are just kind of walking through them systematically, and so hopefully they'll be helpful to you. This is pretty close to what's in the notes too. But if you work through your problems, your chemical problems, just keep these in mind. So that concludes Unit 2, or sorry, not Unit 2, Unit 3, hello. Practice, practice, practice. There is a lot of problem solving for Unit 2. We did go through a lot of different varying problem solving skills. So make sure you go through your practice homework problems again before you take the exam. Now you're not given much time on the exam because it's expected that you know how to do these problems, and you're not just trying to look through your notes and find the answers. So that's why you're not given several hours to work on these exams. You don't have to work on them at the testing center. So you can work on them at home, but you have to know what you're doing. So practice. Let me know if you have any questions, and I will see you next time for Unit 4.